Okay, good afternoon, good morning, or whenever you are watching this video. So today we will be discussing combined gas law and going through how to work out combined gas law problems. Before we do that, just a couple of announcements. So the first slide on your assignment today is a to-do list for Canvas. You know that I love to-do lists, so I figured I'd make you one this week. And so what you can do is you can go through and you can also check off as you do something, okay? And then once you have all of these things checked off, then you know you have completed your assignments for Canvas. Let me know if you like this checklist. I'll also be posting this in Insta Story later on this afternoon. So the very first thing I need you to do is go and check in via the attendance form in Google Classroom. So there will be an assignment in Canvas that says week 4 attendance check. You will need to go in there and make sure you check in and actually go into the form and sign in for the week. The next thing that you will need to do is complete the mini quiz, and the mini quiz will be via WiserMe. So please make sure you go into WiserMe and go through that as well. And the mini quiz is about 10 questions. It will not go live until 9 a.m. on Monday. So you will not be able to start your quiz early. Please remember that this is a quiz, and I can tell via WiserMe if you are opening different tabs. I can tell when things are copied and pasted. It will give me a little alert. And I don't want you to get a bad grade on your first test and quiz during this new learning environment. So to figure out which time of the week it's going to be good for you to sit down and do those 10 questions. Make sure you have everything that you need in front of you so you don't have to go back and look at things later. Again, you will need to know your Charles Law, Boyle's Law, Gay-Lussac's law, all of those things. And those equations will also be provided to you on your quiz. So I just want you to be as prepared as possible for that. So after you complete your quiz, or you might complete your quiz later, you're going to watch the Combined Gas Laws lecture video. Once you watch that video, you'll complete the gas law problems. The lecture video is what you're watching right now, and then you'll complete the gas law problems. For art this week, you have a digital image illustration to complete, as well as a artist statement for art for your digital illustration that you'll be completing. Dr. Kurt also made a video for that, so be sure to go to the YouTube channel, and I think he also linked it in Google Classroom for to make sure you know how to do those things. Okay, so moving on. What is the combined gas law? So what if the temperature is not constant, the pressure is not constant, the volume is not constant? That means we can't use Boyle's law, we can't use Charles' law, we can't use Gay-Lussac's law. In that case, we will use something called the combined gas law. And just like the name says, it is all of your gas laws combined. So it is a combination of your Charles, Boyle's, and Gay-Lussac's laws all together to make an equation. So the equation for the combined gas law is here. P1 V1 over T1 is equal to P2 V2 over T2. The first thing I hear a lot of students say is, man, this is a lot of variables. And I do understand that. And you are right. It is a lot of variables. Really, the easiest way to go about doing this, in my opinion, would be to make sure that you take your time. And in addition to that, I would probably do a really good job of making sure my conversions were all correct, and make sure everything's in the temperatures are in Kelvin. But for some people, this way is too difficult. So for those students, they then like to use the hold on. Let me go back this way. Sorry, guys. Sorry about that flip flop. People like to use this one where you do P1 V1 times T2 is equal to P2 V2 times T1. I don't particularly like this one because I find myself interchanging T2 and T1 in the wrong spots. It's not P1 times V1 times T1. It's P1 times V1 times T2 because, again, we cross multiply the numbers right there. All right. So now let's go through and work a practice problem. Okay. So we have a gas at 300 K. Okay. So let's stop for a second. We know that our equation is P1 V1 over T1 is equal to P2 V2 over T2. So we know that. Okay. Second, what are my variables? All right. So we know we need a P1, a V1, and a T1. And I'll put equal signs next to those. And we also need a P2, a V2, and a T2. Okay. All right. So 300 Kelvin. First thing I see, Kelvin, 300 K. What is that? Is that a temperature unit or a pressure unit? If you said temperature, you're correct. So my T1 is 300. Okay. Then I say it's heated to 1250 K. All right. So that is my T2. Okay. It went from 300 to 1250. And then it says it expands from 600. And sorry for that spelling error. I just noticed that should say new pressure, not new PR or whatever that says. Yep, teacher mistake. So anyway, it says it goes from 600 kilopascals and 20 liters to 40 liters. All right, so 600 kilopascals. What is that? Is that pressure or temperature? I hope you said pressure. So I'm going to put a 600 here. All right. And the volume at 600 was 20. However, I don't know the new pressure, but I do know that it expanded from 20 to 40. Okay. That's all the information I need to solve for this problem. I have one variable. If you do this and you have more than one variable, you need to go back and read your question because you have confused something along the way and you obviously forgot to include a variable. All right, so now I'm going to take this. I'm going to change my color so you can see. I'm going to take this equation and I'm going to plug everything into it. So P1 was 600, so I'm going to write 600. Okay, V1 is 20, so I'm going to multiply that times 20, divided by T1, which is 300. And I was so lucky in this problem because temperature was already in Kelvin. But remember, if temperature is not in Kelvin, you have to change it by adding 273. Okay, and so P2 is, I don't know, and V2 is 40, so I'm going to just write this as 40x. Okay, again, x represents P2, and that's going to be divided by 1250. Okay, I personally, from this point, like to go ahead and cross multiply. So right when I have this, I like to go ahead and do my cross multiplication. If you wanted to multiply these two numbers together first, you could, but I personally like to cross multiply first. So that would end up being, if I rearrange this equation, that's going to be 600 times 20. Then I'm going to go down here and multiply it times 1250. And that's going to be equal to 40x times 300. And to me, that looks a lot more simpler and it's easier for me to go in and do that math. So I'm going to do that now. I'm going to take 600. I don't know why I came up with such big numbers today. Times 20 and times 1250. And I get is equal to, and 40 times 300. So again, I'm just multiplying all those things together that I have, is equal to 1200 x. Now, all I have to do is solve for x, right? So that means that I'm going to divide each side by 1200, just how you learned in math class. Yes, chemistry is a mixture of math and science. Hooray. And I get, I'm going to do it again. So I'm going to do 15, 1, 2, 3, 1, 2, 3, divided by 1200. And I get 12,500 is equal to x. And what unit should that be? Well, it's pressure. And if I go back to my pressure unit up here was kPa. So this would be kPa. And, let me erase that here so it'll be easier for you to see that this should say is equal to x. There we go. Make this equal to x. And so that would be 1200 kPa. And then I would box in my final answer. I hope that wasn't too messy. Again, you can pause this video, rewatch that part to make sure that you understand how to do those problems. Once you practice this problem and you know how to do it, you have 4 problems to try on your own. So they are listed in your slideshow. Again, you can take your slideshow and edit it in Kami. You are also more than welcome to just go through and work them out on the slides. Show all of your work. If you do not show your work, you will not get credit. So please, please, please make sure you show your work. This is not a time to call your friend to see what they know in chemistry. This is the time for you to figure out what you know. On Wednesday at 10:30, I will be working through a couple of these. I will work through maybe 1 and 3 or 2 and 4. I haven't really decided yet. But I will work through a couple of these live on, we're going to do Google Meet this time. So please make sure that you check in the stream of our class and you will see a invite to join me for the Google Meet. And we can get together and work out these problems if you need help. Of course, if you need help before Wednesday or you want to talk to me personally via office hours, please make sure you fill out the office hours form and I will message you and ask you what time is good for you to meet, and more than likely that'll be via Google Meet. Another thing, just want to go in, you probably noticed that I put in grades this week. I got one more class period of week 3 to put in, but for the most part, all your grades are put in. If you see an I there, be very careful because that I is going to eventually change to an M. I tried to make it an I so it wouldn't drop your grade too much right now, but some of you are missing all 3 weeks of assignments. Please, please, please be sure to do your assignments and turn them in. They are being graded, and I don't want anybody's grade to drop at this time. I mean, it's kind of a stressful situation for everyone, and so I want us to do as well as we possibly can. So please, please, please make sure you do your work. If you're having issues with your work and that's the reason why you didn't finish it, let me know, and I will help you. So also remember to check your feedback and look at all of the questions to see what all the comments I made. I enjoyed your Kimbus game. Thank you so much for doing your work, and I will see you guys on Wednesday.